Historically, the placement of fire and gas detectors has been more art than science. Detector placement based on expert judgment has resulted in systems which are inconsistent and, at times, inadequate. Thanks to input from system end users and the expertise of our engineers, we've answered the challenge of designing consistent and effective fire and gas systems utilizing a technique called fire and gas mapping. Fire and gas mapping provides a framework for evaluating the effectiveness of a detection system based in mathematics rather than judgment. It's quickly receiving widespread adoption in the process industries. The process of fire and gas mapping starts by defining a 3D model. This model can either be built using primitive geometric shapes or more frequently utilizes existing 3D CAD models. Our software supports either method and will even allow the user to use a combination of CAD models and geometric primitives within the same study. A hazard assessment, known as grading, is used to set coverage targets for fire and gas detection. The process of grading ensures coverage is provided where required and that the targets for the coverage are commensurate to the fire or gas risks for each geographic area. Higher risk areas, such as high pressure pumps or compressors, produce higher grades and therefore require a higher degree of coverage. Coverage is defined as the statistical probability that a fire or gas release is detected by the system. Calculating the coverage relies on sophisticated computer algorithms. The 3D model is used in these algorithms to analyze the impact of obstructions on the line of sight of detectors and to evaluate the relative locations of detectors and potential leak sources. For optical flame detection, the ability of a detector to detect a fire is impacted by the type of fuel being burned, the detector's characteristics, and the magnitude or size of the fire itself. Our software has an extensive database developed in close cooperation with equipment vendors, which allows the user to characterize the performance of a detector in a large number of applications. This capability is unique among fire and gas software and makes it possible for the user to evaluate the relative effectiveness of multiple detector technologies and hardware selections on the design. Mapping calculations generate both graphical and numerical results and can be performed in one of two ways: geographically or scenario-based. Geographic coverage mapping is used to analyze the fraction of a monitored area where hazards are detectable. The results of geographic mapping are color-coded coverage maps, where the coloring represents the number of detectors monitoring any given area. Scenario mapping utilizes fire consequence modeling, or gas dispersion modeling, as an input. This allows the user to analyze how potential release scenarios overlap with areas where fire and gas leaks are detectable. Performing mapping in this way allows for rich graphical results known as risk maps, which can be used to easily identify weaknesses in the system design. Whether using the geographic or scenario-based method, fire and gas mapping provides unprecedented insight into the effectiveness of fire and gas detection systems. The use of mapping finally allows designers to answer the questions: how many detectors do I need? Where should they be located? And why? This results in more effective, more consistent, and more defensible designs.